All right, everybody, how's it going? So my name is Cameron Dennis. I've been building a Near for about 4 years, building with Near AI for the last about 8 months to a year or so. It's been an amorphic organization. But I'm here with Felix and Marvin. We're going to be talking about the private ML SDK and what it means for verifiable privacy in the world of AI. So without further ado, we'd love for you to introduce yourselves. Felix, you want to go first?
I think he goes first.
Okay, cool. Marvin, you can go first.
Okay. Thanks for having me. My name is Marvin. I'm the co-founder of Phala Network. I'm running a non-technology role called CEO, and we've been working in the space for 5 years on TEE. And basically, in the beginning, like everybody in crypto space hate TEE. It's not purely based on cryptographic solutions, but like we believe there's some big potential in it, and it can scale. To help the Web3 standard eat the Web2 software. So that's basically our what we believe in. So we've been working in the space for a while, and it's super excited to see how AI jump in the space right now, and TE or verifiability can play a part of it. Yeah.
Cool. Well, just before we move on, tell us a little bit more about Phala. Like, what is Phala?
Yeah, Phala in reality, it is an abstraction layer of how TE works in a Web 2 world. So first of all, TE is not hardware, right? Like TE is a systematic work based on how security hardware works, and each chip manufacturer have their own TE systems, such as Intel SGS, Intel TDX, AMD SEV. Apple have its own TE standard, and so when you unlock your face in your phone, you are using TE, right? When you open up Binance with pass keys, you are using TEs. So it's kind of already been widely used, but the trust assumption of this Web 2 TE doesn't fit with how Web 3, use cases works in Web 3 scenario, especially like in DeFi, AI, consumer don't trust the developer don't trust the cloud provider, so we only trust blockchain, right, and ZKP. So how to build a systematic work based on that, it requires some software level of abstraction. So Phala basically do only 2 jobs: to abstract these Web 2 TE standards together and provide a software solution that fit with Web 3 requirements. And another job is that we provide security hardware that fit with these solutions. Yeah.
Yeah, we'll get more into the details in a bit, but Felix, quick introduction of yourself and a little bit about xTrace.
Hi everyone, I'm Felix. I'm the CEO and founder of xTrace. And we are a pretty new company, basically started in June. And what we're building is an encrypted context layer and data and memory for AI agents. So what I mean by that is that every user can upload their data onto our system. And then as a data protocol, we can guarantee that we have no control of your data, so that all the data will be safe and then still searchable by AI agents. So what I mean by that is usually the guarantee for a database holder is encrypted at rest and at transit. And then xTrace gives one further guarantee, which is encrypted in use. So AI agent can still send out encrypted query to xTrace's encrypted database and get the data they want. So this pairs perfectly well with TE because we can essentially allow agents or large language model running in TEs to have data access to external databases. And on top of that, we can also be the persistent storage, which is called memory for AI agents running inside, which allows this to be on persistent storage. It makes the agent running inside stateful. Yeah.
So yeah, just for summarize quickly, there's a lot of words. So in short, xTrace is really providing the personalization like railway. So if you're using an agent and you want to say, hey, agent, go buy me a cup of coffee, that agent doesn't understand like whether you want whole bean coffee or ground coffee or hot coffee or cold coffee. Like it needs to understand your preferences. So with xTrace, you're able to use xTrace to personalize your agent while ensuring privacy, which is really a prerequisite to this like user-owned AI thing that we're all talking about. So thank you. And moving back to Marvin, so your whole mission is to make trustless compute affordable sort of through the private MLSK and also everything else that you're building with Phala. And I'm curious, like, how you see this kind of adoption by developers. Like, do people really care about privacy and verifiability right now?
That's a great question. So, like whenever I'm pitching, I'm not saying, hey, use TE instead of ZK, using TE instead of smart contract on Ether. Our main thought is If you can run something on Ethereum, do it. If you can run an agent on Near, do it. Like TEE is the technology that as a better solution than Amazon Cloud, right? Like it's kind of in the middleware between how Web 2 and Web 3 works. So we are a believer of chain maxing, and we are a believer of cryptographic solutions will merge together eventually. We already see the trend, how this trending works. For example, Phala's TE attestation is already using ZKP to generate the provers, so that you can use the ZK proof to know, as a attestation for how the TE works. So our proposal is like the Web3 adoption will happen on many technologies, working together instead of single tech. So
you said this word attestation.
Yeah.
It's a very important thing that everyone should understand.
Yeah.
Can you quickly explain what TE attestations are?
Okay.
And where they live?
Yeah. So security is based on assumptions, right? Like, for example, like how TE work is, just imagine there's a black box in a CPU or GPU in these chips. And the programs, the data running inside this, we call them enclave, the black box. Running inside the enclave actually is running in secret, but by the attestation system, you can know exactly how this program running as it should be. So how to know it? First, we need to know like how this program looks like. So you probably need to open source to make sure that the others can verify it. And then you put the open source software inside this security chip enclave and execute it with the attestation, which is provided by the GPU manufacturer, TE systems. You can know, okay, this computation result is actually running with a specific hardware environment with a specific software version, so that okay, with the attestation proof, how this program is running as it will. So that's the very basic, very rough, abstract description of how TE works. But in reality, it's more complex. For example, right, it's based on a security assumption for the hardware. So what if you don't trust in the hardware, right?
These things have been hacked.
Yeah, it can be hacked.
Yeah.
It can be hacked.
Yeah.
So you should know these security assumptions before you use it. And another thing is there's for example, with the attestation, it's not as simple as ZKP with single prover. You can attest the entire, Merkle tree or the entire hash, history behind it. With TE attestation, it can separate the verifiabilities. So, for example, some proof actually means that the environment setup is correct. Some proofs means the Docker, runs at will. So, et cetera, et cetera. It can be separated into very different layers. Yeah.
So now we have a general idea of how TEs work and what they are, but Felix is a bit more on the RAG pipeline.
Yes.
So can you quickly explain what RAG is, what it stands for, and exactly what XRAG is, the sort of new primitive that xTrace introduces?
I think to me, AI agent is composed of basically 3 components, right? Like the large language model, the second is a RAG and dynamic memory, and the third one is a tool call ability. And then
what is it, ability?
Tool call.
Tool call.
Yeah, like calling APIs to execute certain functions. And then what RAG is basically allowing, you can think about when you're training a large language model, it's kind of like a training school, and when you're doing the exam, the RAG is like an open book. So a way for AI agent to reference outside data that is not outside of the training data. That can be like real-time data or like proprietary data, private data, or all of that. And then what we're trying to do is that we're making sure that all the data stored inside our vector store are all encrypted. And there's still available to be semantic search on. So what semantic search means is that the agent can send out a query and then find the most relevant data in the whole vector store. And we're making the whole process encrypted, which means that the query is encrypted, the data is encrypted, nothing is leaked in the protocol, and then still the agent can find the response they need.
It's critical, super important.
Yeah.
How do you anticipate this actually getting out to the masses? Do you have to natively integrate with xTrace every single time? Can these agent frameworks sort of add xTrace by default? Can this be added to the private ML SDK so everyone that uses the private ML SDK benefits from private RAG or encrypted memory?
Yes, or like design is really modular, so we allow like it's chain agnostic and also agent framework agnostic. As long as you have data that you want to work with certain like agent framework, then you can use your system and then make all the data you want to interactive encrypted. So we really see that working with all the agent framework will become like this distribution channel. And then our ultimate vision is allowing like one user to upload all their personal data into our data layer, and then they can choose the data access control to different agents they're working in. For instance, they can only open their e-commerce like habits to the e-commerce agent, and then the text data to the text agent only. So that they have one unified layer that has like shared memory and like kind of gather all the fragmented memory and still work with all the different AI agent, AI apps they want to work with. Yeah.
So I'll say, I'm working closely with these guys because honestly, I want a solution, which is I want to be able to have a single window that have an agent watch my screen at all times, verify that none of this data is being leaked to some third-party cloud, and it suggests questions that I can ask on calls, and like suggest things that I should do with my browser. And so this is what I think that we are all sort of building towards, like this private ML. But I was recently at an AI conference where everybody didn't think private ML was ever possible. But now we see things like NVIDIA coming out. All new H100s, H200s will have this TE support. And so this demand is not coming from crypto land. It's coming from like the large compute providers, or like NVIDIA, Intel.
Yeah.
Like, how do you sort of see this sort of playing out long term?
I think a very important reason is like actually we know the information about private ML in not know the concept of this technology, but more like how the business already been working for a while through the last I think IC3 conference in San Francisco. Like it's more like an academic one, and actually the researchers from NVIDIA, Intel, OpenAI, all of these guys are there. All of them know that private ML is already working, and but unfortunately, it's more targeting on the enterprise level of users. The only company who actually doing a good job using TE for a private AI is Apple. All of the Apple intelligence cloud service going through the TE cloud powered by Apple M3 security chips. So like exactly the chips running inside these Macs. So, but I'm thinking like now it's more targeting on enterprises, but it's going to be consumer facing. Like I'm not sure how many of you guys already used OpenAI operator. It's terrified.
Yeah.
You have to like kind of like type in your login and input all of the password in the cloud browser, so that this agent can operate jobs for you in that cloud browser. And it is having mass adoption to their consumers. I'm saying I don't trust it.
No.
Yeah.
I think I saw in Microsoft like the new. I think it's taking screenshots of your window pretty much like every X amount of seconds. Yeah, it's horrifying. I don't want that. So Felix, for encrypted memory, xTrace, what are the industries that you're really looking to kind of go to market with?
Yeah, I think currently we're just observing like a burst of like agent framework building, like a lot of agent launchpad, and everyone's trying to kind of work on the agentic side. And then we're really looking into two sectors. So one is like just an encrypted knowledge base, like how RAG works. The second part is on encrypted memory, because this memory that is generated by large language models through like all this test time scaling and a lot of reinforcement learning is really valuable. And I believe that this new memory, encrypted memory, will unlock collective intelligence between AI agents, so that each AI agent can co-own the data that they generated or own it by themselves. And I think this new paradigm is like where the new data opportunities unlocked. So we can kind of make a multi-agent collaboration really happening while all of them have their own data. Because currently what I'm seeing is that a lot of multi-agent collaboration is just like the same ChatGPT or whatever large language model with different prompts. I think what really makes it different for multi-agent collaboration is the data they have access to, the proprietary data, the past experience they have. And that will really make a difference when different agents are working together. Yeah.
I am super bullish on this approach. Like, I think privacy is just like a basic feature. but like very few people or enterprises will pay for privacy. That's the reality. But based on this fundamental of privacy, you can build very good ideas. For example, in a private RAG scenario, I would say I'm super bullish on the shareable memories because my pain point is I'm using Anthropic, I'm using OpenAI, and I have to upload everything about TE and Phala again with a lot of my tokens. I believe many consumers feel the same too. But with if there's a like personalized memory database that I can upload my knowledge for once and it can be shared and used to many different agent platforms, that would be A, super convenient, B, save a lot of computing resources.
I'm kind of curious, like, I think one of the biggest issues that we're all going to face in this like privacy verifiability world is actually getting the real world to trust the code, trust cryptography.
Yeah.
How do you see us actually bridging that gap? Do you think it needs to come from trusted organizations like Apple, or can it come from, applied cryptography labs or companies?
That's a very good question. It's a tricky one. Like, for example, what's happening on Safe right now? It's kind of a good sample. I'm not saying, I think Safe have one of the best security teams in the world in Web3, but like the Babbitt hack vulnerabilities is not because of the contract, right? The contract is verifiable, so everybody's using it for millions of times, so it's safe. But for the how the front end and the server end works, they still need to use some dynamic backend for the user experience on the front end. And of course, there's tons of alternative front end for safe, but still North Korea in, right? Like why? Because as long as you are using server, there could be vulnerabilities. How to save that? I would say, I'm not saying TE can save the issue. TE can't solve this.
But would it be like a standard? Does it have to come from a company? Does it have to come from a government? Like what will get people to trust verifiability in cryptography?
Yeah. I mean, but I'm just trying to address that. If you put how the backend of Safe works and how the front end works, A, open source it, right? So that everybody can reproduce it by yourself. B, providing centralized service is okay, but for example, running inside TE, at least the security, the white hats can always tracking the attestations of these backend logs to see if there's anything weird happening, to see if the hacker changed the front end and back end code, without your knowledge. Like the more exposure of transparency logs from AI and back end or front end, the better.
Yep.
Yeah. That's my point. Yeah.
That makes sense.
For me, my security assumption kind of based on like the HTTPS protocol, like using similar like encryption method and AES encryption. So kind of like if you want to say I'm unsafe, you have to first break HTTPS or AES. So that's kind of how we address a cryptography primitive. Yeah.
So some sort of standardized protocol that really, if you ask the Joe Schmo off the street, hey, what's HTTPS? They're not gonna know or
but
care.
They kind of trust HTTPS as a default, right? Compared to the previous times. I think Google kind of forced it to happen. Yeah, because they have the monopoly of like web search, so they just kind of derank everyone who doesn't have the TLS protocol enabled. So so I think there's some way to make it work.
I mean, this is the last question. It's a little bit far out, but assuming all of this technology ends up getting really proven out and it works, how long do you think it would actually take to get in the hands of everyday people?
Well, I would say it's not a technology question because it's already in there. Like based on our benchmark very early in last year, using TE GPUs like H100, 200, you only have 5% of trade-off to have V level inference for basically any model. So it's already in there.
It's there. And
for AI agents, it's obviously it's already working very well in TEs. So I would say but for training I would say this year is a beginning because trustless or verifiable training is haven't reached like a full kind of status yet. So it's only a matter of time.
We need the hardware.
Yeah.
Like it needs to be everywhere.
Yeah.
It's just happening.
Yeah, and what happened in the market actually helped to pushing that. A lot of like U.S. companies and U.S. citizens don't like, for example, DeepSeek, right? Like we love DeepSeek as an open source software, but you don't trust the inference service from China. So how to solve that? Like we need some trustless, middleware to operate these open source models, and you can see how they collect your data or not collecting your data. So I think it's the market is pushing it. Yeah.
Just to kind of repeat the question, assuming all this works perfectly today, what does the world look like in about 5 years?
Yeah, it really depends on like how good the model is and how good the vertical agents are. So I think currently, the agent still hasn't lived up to its hype yet, but I see a lot of good transformative like breakthrough every week. I'm doing like this nearly week with Cameron about like all the AI research and everything. So I can see it happening, but I think it just takes like that breakthrough point, inflection point. And then when there's mass adoption, then we can see that people actually need to upload all their data to make sure like the agent can get the best out of all this proprietary or personalized data. Yeah.
Thanks. Well, guys, that's about it. We'll be around if you have any more questions. Thanks for listening.
Thank you.
Thank you.